In this video, we'll go over autosaving to WAV files. We can only save waveforms to WAV files. And we can only save one waveform at a time to a WAV file. If we want to save multiple waveforms, we will need multiple autosave steps. I'm going to save out the recorded time waveform on my reference mic to a WAV file. If I apply this step again, it's going to ask me if I want to replace it. We actually can't append to the WAV file, we can only overwrite. Because of this, it's important to set your file name construction to not overwrite any data that you wanted to save. One good approach would be to change the name to save at the timestamp. Now when I run the sequence, it will have the sequence name, but instead of the date, it will show the time. So as long as I'm at least 1 second apart, SoundCheck will save two different WAV files. The only option that we have in autosaving to WAV file is the scaling. We're taking data that is measured in pascals and converting it to full scale. You can choose three options: normalize to peak, use the sound card values, or user defined. We can also adjust the bit depth. Right now, I'll select normalize to peak. The important thing to remember is that when this waveform is in SoundCheck, SoundCheck knows the y-axis is in pascals. But the second we remove it and save it to a WAV file, that WAV file will only be defined in full scale. To understand some of the scaling numbers, we can look into this waveform. If we normalize this to peak, it's taking the greatest amplitude, either negative or positive, and making that fully saturated full scale. So quickly, if I just take a post-processing step, and it looks like down here is the greatest magnitude of this. I'll increase the significant digits a little bit, and we can see that the lowest point is 2.0207. This occurs at 610 milliseconds, so right around here on the graph. That's why when we select normalize to peak, the full scale value gets automatically set to 2.0207. I'll save this data out normalized to peak, and we'll take a look at it in a third-party program called Audacity. This is completely independent of SoundCheck, and when we save out of SoundCheck as WAV files, those WAV files can be played in any program that can handle them. In Audacity, I'll open up the WAV file I saved. And you can see on the y-axis the scale is 1 to -1, and we're completely saturated. That peak we saw at 610 milliseconds is at exactly -1, which is the full dynamic range of a WAV file. So let's look at what happens when we choose different scaling. Now I select sound card values, and the full scale changes to 508.55, which is much higher than we had before of only 2 pascals. Setting scaling to sound card values is dependent on what hardware we are using. If we go to Setup Hardware, my reference microphone is on input 3. Input 3 is an amp connect, and the VP value is 10.171. That means to be fully saturated on the input, it would need 10.171 volts. My input is the reference mic, so if we go to calibration now, we can see the sensitivity of my reference mic is 20 millivolts per pascal. So if the maximum input voltage is 10.171 volts, and the reference mic sensitivity is 20 millivolts per pascal, then it would require a signal of 508.55 pascals to be fully saturated. Using the sound card values sets the maximum available saturation of your physical input to the maximum saturation of the digital WAV file. Because we're only recording in the tens of millivolts, our WAV file will be a comparatively low signal. When I bring this file into Audacity, you can hardly see the level. Now I'll just bring them both into SoundCheck. And again, when we compare the two on the same graph, there's a huge discrepancy. The benefit of using sound card values is you retain the difference level. If I have different level signals recorded, when I save those to WAV file, those differences will be maintained. If everything's normalized to peak, it'll make the best use of the headroom, but you'll lose those differences. The choice is dependent on your application. The last option is for user-defined. Here, you can set any level of pascals as your full scale. If I set this to 20 pascals, when my recording was at 2 pascals, the level of the WAV file in full scale will be much higher than if I use sound card values, but still lower than if I normalize to peak. If I bring this audio into Audacity, you can see the difference between the three. Thanks for watching. If you have any further questions, feel free to email support@listeninc.com.